You are falling right now and you don't feel a thing. There's a number called escape velocity, and one place in the universe sets it higher than light can reach. That place is a black hole, and by the end you'll know exactly why not even light gets back out. We're climbing the ladder of escape, one rung at a time, until the rungs simply stop existing. Rung 1 is home. Leave Earth for good and you need about 11 kilometers a second. That's the Saturn V, 3 stages, 1 job, 1 brutal number to hit. Miss that number by even a little and gravity just pulls you straight back down. The International Space Station hasn't escaped anything. It's just falling around Earth, forever missing the ground. 11 kilometers a second is already faster than a rifle bullet leaves the barrel. Escape velocity doesn't care what you're made of. A feather and a battleship both need that exact same speed to leave. Every planet has its own number, and bigger planets ask for a lot more. But planets are lightweights. The real climb starts with a star. Rung 2. The Sun escaping its surface takes over 600 kilometers a second. That's about 50 times harder to leave than Earth, from a star that's already trying to cook you. 600 kilometers a second, and you'd still be leaving from a surface hot enough to vaporize steel. At that speed you could cross from New York to London in about 9 seconds. The Sun has spent 4 billion years doing this without ever running low on gravity. And the Sun isn't even a heavyweight. As stars go, it's fairly average. So what happens when a star runs out of fuel and gravity finally gets to finish the job? Rung 3. A white dwarf, what's left after a star like the Sun burns out, packs almost the Sun's entire mass into something roughly the size of Earth. A teaspoon of that material would weigh several tons on Earth, more than a small car, closer to a small elephant. Cram that much mass into that little space, and escaping suddenly costs thousands of kilometers a second. White dwarfs don't collapse any further on their own. Something has to squeeze them harder from outside. Gravity doesn't care that you brought a whole star's worth of stuff. It only cares that you crammed it small. Squeeze that same star even harder, though, and you don't get a white dwarf, you get something stranger. Rung 4. A neutron star, the Sun's mass squeezed into something the size of a city. A neutron star used to be a star many times more massive than the Sun, before it collapsed. Drop an object from waist height here, and it would slam into the ground at roughly 2,000 kilometers per second, thousands of times faster than a bullet. Its gravity is so extreme that light leaving the surface visibly bends around it. To leave one behind, you'd need to hit nearly half the speed of light. No human spacecraft has ever gotten within a fraction of a percent of that number. And neutron stars spin, some of them faster than the blades in your kitchen blender. Remember rung 1, the 11 kilometers a second that felt extreme? This rung eats that number for breakfast. Half the speed of light sounds like the ceiling. It is not the ceiling. Every rung so far has demanded a bigger number. The next one demands all of them at once. Squeeze a neutron star's mass down just a little further, and there's no floor left to hit. Rung 5, a black hole. Not a star running low on fuel, gravity with nothing left to stop it. Nothing about the black hole itself is exotic matter. It's ordinary mass, just impossibly concentrated. There's no surface here, no ground to stand on, just a boundary called the event horizon. The event horizon isn't a physical wall you'd feel yourself hit. It's just the line where the math flips. Cross that boundary, and the escape velocity there is exactly the speed of light, which means the fastest thing in the universe is right at that line, exactly fast enough to fail. So why can't it just go faster? Because past the horizon, speed stops being the problem. Space itself becomes the problem. Here's the reframe. Past that line, every direction you could possibly move already points toward the center. It's not that gravity outmuscles light. It's that space itself has folded so every path leads inward. Once you're past it, every single possible future you have points toward the center. That's the answer to the question from the start. Light doesn't lose a race to the black hole. There's simply no out left for it to run to. That's the pattern hiding under all 5 rungs. Gravity was never really about pulling. It's about how space bends. A black hole just bends it all the way over. Every rung before this one bent space a little. A black hole is the one place that folds it into a one-way door, and that door only gets bigger. Feed a black hole more mass, and its horizon grows to match. Some sitting at the centers of galaxies weigh as much as billions of suns. Ours, at the center of the Milky Way, is comparatively small, and it still swallows light for a living. Which brings us back to the question this whole ladder was built to answer. Why can't anything escape? Because past the horizon, escaping was never the kind of problem speed could solve. Here's the part that surprises people. A black hole isn't a cosmic vacuum cleaner. Black holes suck in everything nearby like a vacuum. Same mass, same gravity, nearby objects orbit fine. People imagine black holes reaching out and grabbing ships that wander too close. That's not how any of this works. Swap the sun for a black hole of the exact same mass, and Earth would keep orbiting exactly like before. You'd lose the sunlight. You would not get pulled in any harder than you already are. Distance still protects you the same way it always has around anything with mass. The danger was never gravity reaching further. It's what happens if you get close enough to actually cross that line. Get close enough, and tidal forces would stretch you long before you even reached the horizon. Scientists call that spaghettification, a genuinely ridiculous word for a genuinely horrifying process. So the black hole itself isn't the trap. The horizon is the trap, and only the horizon, which makes a black hole less like a monster and more like the universe's only true point of no return. Every other rung on this ladder you could theoretically outrun with enough fuel and enough time. A black hole is the only rung where fuel and time both stop matching. Somewhere out there, a black hole has been sitting quietly for longer than our species has existed. It isn't hunting anything. It's just doing what gravity does, taken to its absolute limit. Everything else on this list is a wall you can eventually climb. This is the one wall with no other side. So the next time you look up, remember that some of that darkness isn't empty. It's the door. And it only opens one way. There's one more twist we didn't cover. What happens to time itself at that same horizon? And it's even stranger than the speed. That's the next climb. Subscribe and come stand at the edge with us.